So now your x-intercepts, if you remember, this is going back, so it may, just remember, this is something you learned in previous years, that x-intercepts are your solutions. And if you want to find your solutions, one thing you can do, this is in factored form if you want to look at it. Isn't this x times the square root of x plus 4? So to find solutions, what you do is you set y equals 0, right? Remember how when you factored something, then you set it equal to 0 and you solved it? So what I'm going to do here is I'm going to set my y, which is f of x, I'm going to set it equal to 0, and it's factored. So do you remember, these are two things multiplied together, so I say, okay, I take each of the factors. X is a factor. I set it equal to 0, and then this is another factor. I set it equal to 0, and I solve. Okay? So this is old stuff, right? What's confusing is they threw all this stuff in here because we still need to remember it all. And we'll talk about why they're asking us a second question in a minute. Let's just answer this first question. So x is 0. That's a solution, isn't it? How would you solve square root of x plus 4 is equal to 0? How do you get down to the x if it's underneath a radical?
Square it.
Yeah, square both sides, right? So if I square the square root of x plus 4, it is x plus 4.
So it's just negative 4.
Yep, so you just say, x plus 4 is 0, x is negative 4. So here's what the deal is. They're wanting these numbers, so that's part of the problem here. Part of the answer is these two. These two things are part of the answers. And you have one of these to do on the quiz, but it's more normal looking. It's one of those things where you have to factor x squared minus 2x minus something, but it factors, okay? So you just remember you're trying to multiply to get the number on the end, add to get the number in the middle when you factor, right? All right, so now what I have here is I have an interval. If I put it in order, it would go from negative 4 to 0. And what they're telling me by the second question is basically that there is some, remember, which one of these theorems, I'll just tell you, it's Rolle's theorem. Rolle's theorem says that if you have two x's with the same y value, if these are y x-intercepts, y equals 0, they got the same y value. This is the point negative 4, 0, and 0, 0. Rolle's theorem applies here because this is continuous. So what I can do is show that there is a place where the derivative is 0. So we got to go take the derivative now. I'm going to go to a new slide for that though. Negative 4 and 0, I'm hoping to find something where the derivative is 0, and my function was x times the square root of x plus 4. All right, these are two things multiplied together. So this one, I did not pick this one for the quiz just because you need the product property here. It's the first, if I want to take the derivative, it's the first term times the derivative of the second term. Let me write the second term as x plus 4 to the 1/2. When the derivative be, put the 1/2 out front, and then it's x plus 4, and then don't I subtract 1 from the derivative, from the exponent. 1/2 minus 2 over 2 would be negative 1/2. So it would be x times 1/2 x plus 4, let me come down here, that's not enough room there. It's x times 1/2 x plus 4 to the minus a half power. And then now with the product property, I have to add, okay, I took the derivative of the second term. Now I'm going to write down the second term and take the derivative of the first term. But the derivative of x is just 1. Hallelujah, right? So let's see at what we have here. If I put the x, this first term, I can simplify it a lot. The x goes on top. Isn't there a 2 and an x plus 4 in the denominator to the 1/2 power? Isn't that negative 1/2 mean move it to the bottom, right? Okay. And then I've got square root of x plus 4. Okay, so that looks nasty, but let's think about it for a minute. They want me to set the derivative equal to 0. Couldn't I just take this f of x right now and set it equal to 0, and I could actually maybe solve this a little easier? This is a harder problem than on your quiz. Your quiz one's going to be like a piece of cake compared to this. It's just a polynomial.
Well, you can already have x plus 4 to the 1/2 with the square root.
Yeah, we could do that. We could replace that with a square root. Let me just scribble that out. We could do that. That's going to make it look easier. If I want to solve this, one way that I could solve this is maybe get one term on each side or something. I don't know. Why don't I subtract this one? And one of the reasons I'm thinking I might want to do that, oh, actually, no. Let me write this down. I could try, this is messy to deal with, right? I thought for a minute maybe I wanted to do that, but let's think about this. If 0 is equal to this stuff, what if I got one fraction here with a common denominator? If I wanted to get a common denominator, the reason I'd like to have one fraction, if I have one fraction and I have that whole thing set equal to 0, doesn't the numerator of the fraction tell me where it's going to be 0? If I could make one fraction out of these, if I could get a common denominator, then I just have to set the numerator equal to 0 to solve it. Let me go to a new x over 2 squared of x plus 4 over 2 squared root of x plus 4. Are y'all writing this down? I need you to write it down because sometimes I need you to tell me what was there when I'm using the video. Write it down. If I could get a common denominator, then I could just set the numerator equal to 0, and that would make this an easier problem to deal with. If I need a common denominator, I really need this right here on the other side also. So couldn't I just multiply this by 2 square root of x plus 4 on the top and 2 square root of x plus 4 on the bottom? Okay, so that's 0 equal x over 2 square root of x plus 4. And then over here, it's plus 2 times square root of x plus 4 squared over 2 square root of x plus 4. Now, part of the thing is sometimes y'all don't want to write stuff down, but sometimes when you write stuff down, it really simplifies it a whole lot. When you're trying to do too much in your head, your brain just can't juggle it all. I had to get a common denominator if I want one fraction there. So now I got a common denominator. I really don't care a flip about that denominator because if it's 0, that means, I could put 0 over 1 or 0 over whatever, but the numerator is what I got to set equal to 0 here. So it's x plus 2. Now the square root of x plus 4 squared is just x plus 4, right? Okay. So now I have 0 equal x plus, let's distribute 2x plus 8, right? And that denominator still looks nasty, but I could care less about the denominator because it isn't even going to enter into what my question is here. On the top now I have 0 equal 3x plus 8 all over 2 square root of x plus 4. The only part that matters in this whole thing is setting the numerator equal to 0 because that's how, if I'm going to get a fraction and it's 0, it's got to have a 0 in the numerator. So 3x plus 8 is 0. Just move your 8 on over here. This is not so bad. It looked horrible when we first started, didn't it? X equal negative 8 over 3. Is that number between negative 4 and 0? Remember how we said it had to be between those two numbers? Okay, so there is the place where the derivative is equal to 0 between those two numbers. Let's kind of recap a little bit. That's my answer. That's where the first derivative is equal to 0. Okay, the instructions say determine whether the mean value theorem can be applied to f on the closed interval. Wait a minute, we did this one in class the other day, didn't we? Didn't this one? On page 174, it tells you that the derivative at some point c, and basically this is just the slope formula from back in Algebra 1, the difference of the y's over the difference of the x's. And they give me, is this a point here? Is this x is 0, y is 1 that I'm messing with here? No, that's not what that is at all. Yeah, this is like my A here, and this is like my B here, okay? So what I'm going to do is this. It's like, let me make a little table over here just to make it a little easier to keep up with stuff. X is 0, and then x is 1. I'm going to plug them into the function. Okay, well, what is 1 to the 2/3 power? 1 to any power is just 1, okay? So remember, that was my A, so this is my f of A right here that I'm going to plug into my formula. Because remember, I'm just going to do the slope formula on these points, and I just have to find out what's the y value that goes with 0. What's the y value that goes with 1? What is, whoa, what did I do? I plugged in the wrong thing. Okay, it was 0 to the 2/3 power. I got ahead of myself. It's just 0, right? 0. So I've got the point 0, 0. And then I plug in, well, what's 1 to the 2/3 power? It is 1. So I got the point 1, 1. That's just like old stuff you did way back in pre-algebra and Algebra 1, right? So we're just finding the y values that go with it. Now my derivative at C, the mean value theorem, is just basically telling me is I can find the average rate of change over this interval. A lot of times calculus is dealing with the instant rate of change, but the mean value theorem says, hey, I can still figure out what that old average rate of change y'all were messing around with in 7th and 8th grade was, and this theorem tells me how to do it. I'll take the slope, I'll use the slope of these values here. So the f of b, this is b right here, so f of b is 1. So f of b is this 1 minus f of a, which is that 0, and b minus a is 1 minus 0. That's 1 over 1. The derivative, the average rate of change in this for this function is 1. Now, where does it occur? That's what the mean value theorem is trying to help us find. We don't have to do it too much, but where does that occur? How can I find where the derivative is 1? Well, let me go back and take the derivative. So the second part of this is this was just the slope formula, and you'll see that on page 174. But if the function was this, and I take the derivative, hey, that's not a hard derivative, is it? Drop the 2/3 out front, write your x down, and then subtract 1. So 2 over 3 minus 3 over 3 is negative 1 over 3. So let's clean that up a little bit. Isn't that 2 over 3, and isn't x to the 1/3 power? The negative's going to move it to the bottom, but isn't that just the cube root of x? So what I need to do is if the average rate of change is 1, and that's the first derivative, is I'll just set this equal to 1. 1 equal 2 over 3 cube roots of x. And you know what I would do here? I have a fraction on one side of my equal sign. One easy way to take care of this is to make the other side a fraction and cross multiply. Do you remember how you can use ratios like that to make your life easier? So that would be, if I cross multiply, 2 is equal to 3 cube roots of x. How am I going to get the x by itself? Yeah, except before I go cubing it, it's kind of under a grouping symbol, so that's kind of like, P really stands for any kind of grouping symbol. Let's get rid of that 3 first, just so it's a little easier. Yeah, so divide it. 2/3 is equal to the cube root of x. And now let me cube both sides to get that x by itself.
8 over 27.
Yep, 8 over 2 cubed, remember it's the whole thing, so I should put that in parentheses. 8 over 27 is x. At x equal 8 over 27, that's my answer. That's where the average rate of change is occurring in this function between the 2 points that they gave me.
To find